All right, let's look at Chapter 13. Chapter 13 is the last part of our cardiovascular system that we're going to be looking at. So this one deals with blood vessels. All right, so the first blood vessels we're going to talk about are arteries. Now, arteries by definition are vessels that transport blood away from the heart. And most arteries are high in oxygen and low in carbon dioxide. The exception to that are the pulmonary arteries, which are the reverse. They are low in oxygen and high in carbon dioxide. All right, so a small artery is what is known as an arteriole. And this communicates with a capillary network. So if we go to this picture here, this is showing an arteriole here. Here's a capillary network. All right, so a couple definitions I'm going to give to you. You've probably heard of these before. One is vasoconstriction. Vasoconstriction is a decrease in the diameter of a blood vessel. So the smooth muscles of the tunica media, which is the middle portion of a blood vessel, are going to contract, and that's going to actually increase blood pressure. So when you make the opening smaller, the blood pressure goes up. All right. Next is vasodilation, and this is an increase in diameter of a blood vessel. So the smooth muscles in the tunica media relax, it opens up some more, and this decreases blood pressure within that blood vessel. Next are capillaries. So this is showing capillaries. Capillaries are, these are very small blood vessels that connect an arteriole right here to a venule, which is a small vein. All right. These are the areas of exchange. So this is where we're going to have gas exchange between body cells and the blood. And it's also where we're going to have nutrient and waste exchange. So nutrients go from the blood into the body cells. Waste products go in the opposite direction. All right. So we go from a capillary network, we're going to go into veins. Oh, by the way, capillaries are very, very small. Here is a red blood vessel, red blood cell going into a capillary. You can see they barely fit in there. And, I've already kind of mentioned red blood cells are teeny tiny cells. All right. So next are veins. Veins is a vessel that carries blood to the heart. So most veins are low in oxygen and high in carbon dioxide, except for pulmonary, which is the reverse of as well. Coming back here, a venule is essentially a small vein. It carries blood away from the capillaries to a vein. So let's take a look at the structure of veins and how they are a little different from arteries. So one of the things about them is that veins have thinner walls, so that tunica media, the middle layer there, is much smaller on a vein than it is on an artery. All right, they have a larger lumen, an opening to them. So it is larger on veins than it is on arteries. So if we go to this picture here, this is showing an artery here, thicker tunica media. Here is the larger lumen that we see on the vein. So the artery, vein. All right? So, and then lastly here is that veins contain valves, and that's what we see here. And veins have valves for the same reason that the heart has valves, and that is to prevent backflow from occurring. Okay? So let's look at movement of blood. When we talk about movement of the blood with the arteries, it's fairly simple. Ventricular contraction is what produces the pressure to move blood through the arteries. We look at veins, well, you're also going to have ventricular contraction, but the blood pressure in the veins is fairly low. So as we go from larger tubes to smaller tubes, blood pressure keeps going up, right? So if we go from aorta, our largest blood vessel, to arteries, which are smaller, blood pressure goes up, to arterioles, which are smaller still, blood pressure still goes up, to capillaries, which are very small blood vessels, blood pressure is very high there, all right? And then when we go from capillaries to venules, and then to veins, every time we get a larger blood vessel, the blood pressure goes down. So by the time we get to our veins then, is those veins are going to need some help getting blood back to the heart. So it can't just be through ventricular contraction. So one way is just simply through gravity. If I'm pumping blood up above my heart, well, coming back down, gravity is going to help that process out. Also, veins have these valves which help prevent backflow from occurring. All right? So, you know, in areas where people have varicose veins, that's where you have an incompetent valve that allows the blood to pool. In fact, that's what hemorrhoids are where you have incompetent anal veins. So other ways in which we help blood get back to the heart is through what is known as a muscular pump. So when we contract skeletal muscles, those skeletal muscles are going to pinch on the veins here. And so because of those valves that are there preventing backflow, this makes the blood move in one direction, and that's towards the heart. All right. Another pump that we have is known as the respiratory pump. So the respiratory pump is whenever you inhale, right, you're going to increase pressure in your abdominal, pelvic, and thoracic cavities. That is also going to pinch on the veins in those cavities. And then because of those valves, that's going to push blood in one direction towards the heart.